Hardwood, so again, we have another tree-specific database here as well. And then to round this all off, we've got the cucurbits genome database, which houses information about melons, cucumbers, gourds, that sort of thing. So you can see there's a variety of websites that are hosted via our Tripal software. They all look different. They all have control over the way that their sites look and the information they provide. To give you a little bit of background information on Tripal itself, Tripal is a community. It's not just some software, and I think this is the value in what we offer. There's a worldwide community of sites around the planet. We provide online monthly meetings, so people join from around the world. We do online training, help sessions. We do in-person workshops at conferences. We have a yearly code fest where groups of us come together from around the world to just hack at the code, either directly or indirectly at the code. We also have an inclusive and a formal governance model to guide our community as well. And I'll talk about that a little bit later. But one of the important aspects of Tripal is that we have a programming, an API, an application programming interface that allows people to do their own development. And so one of the target audiences for Tripal is these non-model species. And typically we don't have as much funding in the non-model species as say a model species would have. But at the same time, with the larger amounts of data that we have the same need to develop and provide the same cyber infrastructure that these models databases provide. And so that's what Tripal does. And by coming together across the globe to develop resources together, we can share those, we can reduce duplication of effort, we can ensure consistency of standards, and then we can also reduce essentially overhead and budgets that are required to maintain sites. So to this end, we have a developer's guide, which allows other users to extend and expand Tripal. So for instance, we have over 40 different externally created extension modules that have been created for Tripal. Those are available online and accessible. And to help ensure that we have quality control, we also provide things like module rating systems. So developers can rate their modules, say with bronze or gold or silver badges. And we also have a governance structure. So we have a project management committee, which is myself there and two other collaborators and colleagues. And our purpose with this project management committee is to make sure that the code has quality controls in place and documentation standards. And then also we have an advisory committee, which is made up of folks from around the world who are stakeholders who often run their own Tripal-based websites. Our chair is Mike Staten at the University of Tennessee, and then there's representation from us from the PNC, so that we have some crosstalk between those committees. We also work closely with the AgBio data group. Many members on our advisory committee participate in this group. This group is dedicated toward ensuring that standardization of practices and protocols are developed across agricultural databases. They have weekly meetings. We've published papers together, and so it's actually a really active community. But just to give you a quick overview function of what Tripal provides, really it's a publishing tool. It's generic in the sense that people can publish really any type of biological data that they're interested in. So here's just an example from Nopos for the lentil organism page. Here's an example from a gene page from the citrus genome database, which I didn't show. Here's a germplasm page from CottonGen, or different phenotypic data related to this particular germplasm. And then we have a variety of loaders. So those of you who work with genomics data will recognize some of these data formats. So we have data loaders for common data formats that are used within the broader community. But also we have things like a bulk loader. So if your data is in tab delimited format or it's not in a format that's standard, you can still get your data into it. And of course, as I mentioned, we have an API as well, so people can write their own extensions and loaders as well. So just like the previous tool that was mentioned, Tripal is based off of Drupal. Drupal is a content management system, and the nice thing about Drupal is it allows the end user who might not have programming skills to be able to go in and change information. So this is really helpful and useful for curators who might be curating the data. It's also useful for communities. So maybe project PIs or directors who might want to come in and add information, don't necessarily need to contact the programmers to do that. So So Drupal makes a nice addition for that. We have two of our Tripal databases have actually created online portals on the same website that houses genomics data for their workshops, their community conferences and workshops. So it makes a nice bridge in terms of integrating data, social aspects, research aspects within the community. Drupal allows each individual site to customize the way that their site looks, so they're able to share even down to the atomic level of attributes of data. They can disable them, turn them on, share them, hide them, put them wherever they like on the web page. And of course, by default, Drupal offers web services, which are RESTful, they're discoverable, and I'll talk a little bit more about that here as we get into the data model, which is the next thing, the data model. So the reason that I wanted to talk more about this for this group was, we're talking about data exchange, how we can exchange data. One of the challenges that we had, as I mentioned before, we had 3 different tree databases, right? We got hardwood genomic tree genes, and we have rosaceae, GDR. We also have several lagoon databases that are running Tripal. Those sites wanted to exchange data with each other, and the current underlying model that we had for storing data just wouldn't support that very well. And so similar to the tool previously, what we did was we completely redesigned the backend to use a more flexible data model. I just want to describe that a little bit. The way that our data model works internally is we refer to everything as what we call an entity. You can think of this as a single data record, or in the parlance of the semantic web, it's a resource. And so for this example, we'll just talk about a gene entity, or a record that might refer to a gene. In this particular data model, there's only 2 required fields. There's an ID field and a type field. And all of the fields within the data model, of course, are key value pairs. So this is very reminiscent of the semantic web, the Tripal data store that was just mentioned in the previous talk. And so the ID and the type will have values. And so here's just 2 examples of some values. So the ID might be a URL, a location, a unique location on the web where this particular entity can be found. And then the type, which is always a control vocabulary term. And so for those of you familiar with semantic web and for Tripal data stores like we just mentioned, you'll recognize this. But what we've done is we've taken it from the semantic web layer and we've actually embedded it down into the software itself. Then the next part of this data model are what we call the optional or the site-defined fields. And so these are also key value pairs. They must be control vocabulary terms. The keys must always be those. But really, the way this works is that each site defines its own field. So there is no predefined, community-defined data model for every data type. And the reason that we went with this particular model is making this everything optional is because we realized when we went to just come up with a way to allow our sites to exchange data, that it would not be practical to have everybody come together in meetings to define how every single data type for every atomic piece of data that is going to be in the database and come up with standards for all of those, especially considering that each site would have different types of data and different requirements for how they wanted to organize that data, and for good reason. And so this allows each site to kind of define their own data models, but even though they can define their own data models, it still works within the software. There's also nested data as well, so it's nested key value pairs where the keys are always control vocabulary terms. And so the underlying theme here is that everything has to use control vocabulary terms. And so in the example here that I've got for organisms, where you got genus and species and labels, those come from the tax rank vocabulary, and then RDFS is a term for the label. So the way this data model works is the data model sits on top of the stack. Below that, you've got our Tripal storage API, and what that does is it works with the translation layer that then sits right above the storage layer. The storage layer is the actual database where the data is housed. So Tripal by default uses Chado, and so for those of you who might not be familiar, Chado is a relational database schema that was developed probably about 15 years ago. It's been updated since then, but it was community developed for storing genomics, genetics, and other types of data. It's a relational database which is very highly structured and tightly has tight constraints with it. So the data stored in Shadow, we have the translation layer that then talks to the triple storage API, which converts the data into into our data model. The data model is then used for delivery of data, whether that's on the web page or on web services. This ensures that the data is consistent, so you don't have data that's appearing on the web page that doesn't show up in web services, and vice versa. And so what this means is that by default in our web services, they're all defined using control vocabularies. They're ready for the semantic web because they're RDF compatible. They are compatible with linked data. They're triple based, so you have the subject type, object, the relationship type. We use the Hydra vocabulary, which is the W3C consortium vocabulary for making APIs discoverable. And what's nice about these web services is they're not triple specific. They're really designed for the semantic web, and they can be consumed by anybody, regardless of whether there's a triple site or not. So these are the three sites that I mentioned before: TreeGene, the Genome Database, Rosacea, Harvard Genomics. These were all interested in sharing data amongst themselves, but they didn't necessarily have the storage space to be able to store the same data, and they really wanted to work together. They didn't want to compete and take each other's data. And so this data model allows for that, not just via the web services that are provided by default, but also we've created extensions that share these models with Elasticsearch. So for those of you not familiar with that, it's a NoSQL, very fast querying tool that makes cross-site searching easy to do. And so here I've got a screenshot on the left showing just the cross-site search tool that's on hardwoodgenomics.org that allows people to search for genes or anything that has annotations that might be across all three different sites. But you might be wondering, well, if the data model allows that much flexibility, such that each site can really define their own data model, how then are they really able to exchange data? And so there's really two ways. One is that sites can specify data of known vocabulary terms from other sites. So if you know the data types the other sites are providing, you can specifically target those. The other thing is that because all these sites are using triple, we have default settings that are based off of the underlying data store, which allow the sites to talk to each other. So for instance, for our gene model, we've got a variety of already established, ready to go terms. That doesn't mean that the sites can't tweak them or change them, but it kind of supports being able to exchange data that way. But also, even if you don't know what the other data types are, or the ancillary data, the metadata provided by the other site, because we have this consistent framework based off of control vocabulary, that even if the site itself doesn't necessarily understand the data, if it knows it's pulling information out of genes, it can display that data generically. It's got information about the terms, the definitions, and the end user can then reason and make sense of that data as it's presented to them. So the take-home message is, what we really try to do is, of course, meet fair data principles. The data model supports flexible enriched metadata just by nature of the fact that it's using control vocabularies and the data store that we have. The data model enables web services that's understandable by humans and computers. It forces use of control vocabularies. And I bolded here in red, the data model is generic, and so it can be implemented by other non-triple sites. And so our hope is that perhaps this particular model might be of interest for development by other sites, and that we can not only exchange data between our triple sites, but maybe as well with other sites that might be housing genomic or genetic or other data. And of course, reusability. It's set up for Providence Suite. This is one area we probably need to do a little bit better on in terms of at least providing data licensing and that sort of thing. But we're moving in that direction. Just as acknowledgement, as I mentioned before, Triple is a community of users and developers. So it's just to thank all those people who've put a lot of time and effort into it, who really feel very strongly about working together as a worldwide community. I've listed some of the industry, the national grant level, and the nonprofit groups who have provided funding for core Triple itself, but also want to acknowledge the funding sources who supported development of these community databases as well. If you're interested, we have a variety of online help information, the Triple website documentation, our codes on GitHub, it's all public and open source, API specified. We have an active community on Slack if you're interested in joining and talking with us. but then we also have mailing lists, and we tweet from time to time. And so that was all I had. Thanks for your attention. I'd be happy to take questions.